Hi, my name is Ansley Gavron, and this is my Lab 3 for Physics 2211. So for the introduction, the lab is split into two parts. Part 1 is you find the mass of a black hole using only the forces from a given star. And Part 2 is to find the initial velocity the spaceship needs in order to blast off from a planet that orbits a black hole without crashing into the black hole and the planet. So the previous results, we have the mass of the black hole is 1.1 times 10 to the 34 kilograms, and the initial velocity for Part 2 is that we found to be negative 2.95 times 10 to the 7th and 5.4 times 10 to the 6th and 0. So the basic physics principles used in, we have the mass of the star is given to be 2 times 10 to the 30th kilograms, and the interval of time is 1 day. The net force is only the black hole, so if given the mass of the planet, which is randomly given from the code, we can use the gravitational force formula in order to find the net force. So for the code initial conditions, we have here that was just stated in the one above. And then for the actual code, we find the initial velocity and the final velocity. And then we have the initial and final momentum vectors that we found by just multiplying the mass times the velocity. And then we calculate the change in both of those, and then the change in momentum over change in time. And we set that equal to the net force. And then we also find the parallel and perpendicular components of that net force. And then over here we have just the mass of the black hole. We have that derived from the formula seen in for the gravitational force. So for the mass of the black hole, the net force on the star can be found by observing the momentum. And given the velocity, since momentum is the change of velocity times the mass, net force is change in momentum over time. If we can find the initial momentum and the final momentum, we can calculate the net force. And so Newton's second law tells us that the net force is the change in momentum over time. From the code, we find the mass of the black hole is 1.1 times 10 to the 34 kilograms. So part 2, we need to fly around the black hole and not crash into the planet. So the spaceship needs to have a certain initial velocity. To find this, we know that the mass of the black hole is what from above, and then mass of the planet is 9 times 10 to the 28 kilograms. The mass of the spaceship is 7 times 10 to the 10 kilograms. So the physics principles that we use is that we need to have a greater escape velocity needed to not crash, then we must use the position and velocity update formulas that are right here. And then Newton's second law that states that F net is the parallel plus the perpendicular components of net force, and then also that the change in momentum is the F net. So for the code we have here on the top was my initial trial and error velocities for the X and Y, and then we use the planet and ship position and velocity update formulas. And then over here we just find the F of all the gravitational force of all of these from the planet of the black hole and the ship on the planet and the black hole on the ship and the planet on the ship. And by doing that, we just use the basic formulas of gravitational force. So here are the results. So the calculations finished in 60 minutes, and the ship is now 3.4 times 10 to the 25 meters away from the event horizon. And see, this is the picture that we got because it flies around the black hole and does not crash. So what does it mean? So basically in part 1 of the lab, we said that the net force is equal to the change in momentum over time, and by definition, F net parallel and perpendicular are the rate of change in momentum and its parallel and perpendicular X and Y parts. So we calculate the net force just by using the change in momentum over time because we can use the momentum principle that states that momentum is mass times velocity. So we use this and deduce the net force to just its change in momentum. So the what if. So basically, if you wanted to take a quick look at the black hole and then leave, instead of doing that, if you want to enter around the black hole, you would need to find a different initial velocity, and that would also just be trial and error. And I tried for about an hour of doing this and could not get any numbers close. So yes, so you definitely could use it by doing trial and error. Thank you so much.